Hi, in this video we are looking at lesson 5 in polynomials, and this one is all about finding unknown coefficients. So what I'm going to do is I'm going to give you a polynomial, I'm going to tell you a factor of it, and there'll maybe be a value like a in front of the x squared, and that's what we're going to try and find out. But because we know the factor, it's all going to work out nicely. Let's have a look. So in this question here, we're told that x plus 3 is a factor of this polynomial, and we have to find k. So you can see that k is this value here in front of the x squared. And we're told that x plus 3 is a factor, so that means we can put negative 3 in front of the table, because remember you put your factor equal to 0 to get what the root's going to be, so the root will be minus 3. And that's what we're going to put into our table. Now, we're going to set out our table as normal, so we're going to write out all the coefficients. There's no missing term at all. So we've got a 1 for the x cubed, a 4 for the x squared, a k for the x term, and a minus 18. Now, a good trick in these ones is to sometimes space out a wee bit further than you normally would, because within the nested table, you will sometimes have two terms in the one space. So let's go on as normal. So let's bring down the number 1, multiply it by negative 3, add it to the 4, multiply it by negative 3, and then when we add this to the k, we're just going to write it as k take away 3. And then when we multiply that by negative 3, we end up with negative 3k plus 9. And then when we add these two together, we have got negative 3k minus 9. And as always, I put a box around my end term, which is usually my remainder. Now, because we are told that x plus 3 is a factor, then I know that my remainder equals 0. So the remainder should be 0. And that means that I can put negative 3k, negative 9 equal to 0. And then if you solve that, you have negative 3k equals positive 9, and k equals negative 3. Now the question also asked us to factorise fully. So we're going to go and write out our answer. So we have f of x equals, now we put minus 3 into the table using the factor x plus 3. Our quotient will be x squared plus x. Now you have got here, you've got k minus 3, but we know that k is minus 3. So that third term will be minus 3, which is negative 6. And then we can go factorise fully. Numbers that multiply to negative 6 and add to 1 are 3 and 2. And it will be positive 3, negative 2. So that is it, factorised fully. You've actually got a wee repeated bracket there. Okay, so that's a straightforward one. We're going to show you a harder one now, which is going to involve a wee bit of simultaneous equations. So in this one, we've got two unknowns. We've got an a value and a b value, but we are told two different factors. So that means I can do this nested table twice over. So let's have a wee look. So let's go with the first one. If x minus 1 is a factor, that means I can put the number 1 in the table. So my coefficients would be 1, negative 4, a, b, and negative 4. And you can see I'm spacing it out a wee bit as well. Let's bring down the 1. 1 times 1 is 1. 1 take away 4 is minus 3. Multiply it by 1. Then when we're adding, we've got a take away 3, which brings up a take away 3 when we multiply it by 1. Then we add them together, we end up with a plus b minus 3. You can do that in any old order. I've just gone with kind of alphabetical order. And then times that by 1, so a plus b minus 3. So when you add these together, you have a plus b minus 4 minus 3 is minus 7. So there is your remainder. And then I'm going to do the same thing again, but I'm going to do it with the number 2 in front of the table. So 1, negative 4, a, b, negative 4. 1 times 2 is 2. 2 take away 4 is minus 2. Double it is minus 4. Add it to a is a minus 4. Double everything, so 2a minus 8. Add it to the b, So 2a plus b minus 8. I'm going to double everything and I'm running out of room, so this is why I tell you to space it out. This gives us 4a plus 2b minus 16. And when we add them together, you get 4a plus 2b minus 20. Okay. Now what I've got there is I have got two remainders that both can equal 0. Because I was told that these things I've used are factors, they can both equal 0. And if I rearrange them slightly, I get two equations. I get a plus b equals positive 7, and I get 4a plus 2b equals 20. Now what's jumping out at you? It's a bit of simultaneous equations. So simplest thing to do is go, you could either half the second equation or double the first equation. But we'll stick with what you're probably used to, which is doubling the top equation. Now actually I should probably times this one through by a negative. If you're one of my pupils, you're probably used to always having the middle ones being a plus and a minus. So let me just change that a wee bit. So this is going to become negative 2a, negative 2b, and negative 14. And the bottom will stay as it was. Then we can add these two rows together. 4 take away 2a is 2a. The middle ones will cancel out and you get 6. So a is the number 3. And then finally, if a is 3, you've got 3 plus b equals 7. So b equals 4. So just to conclude the question, a is 3, b equals 4 is our final answer. And the question only said to find the values of a and b in that case. So if you've got access to TJ textbook at this stage, I would recommend you go try page 114. I have selected these questions here because I think that should be enough practice. Remember, check your answers, see how you get on. Thank you.